In this tutorial, I'm going to explain uh, exact differential equation and integrating factor. So I will first show you how do you find the integrating factor, and then I will explain an example. So in order to have a differential equation, first order differential equation to be exact, it has to be in the form. So for this differential equation, you assume that there is a potential function psi, which is a function of x and y, and you just set psi equal to c. So you take the exact differential of psi, which is psi sub x dx plus psi sub y dy equals 0. And we are going to assume that this differential equation is not exact. So we are going to multiply by mu psi x, and then we are going to differentiate with respect to x, with respect to y. We're going to differentiate with respect to x after multiplying by mu psi y. So looking at that, we can find a differential equation for mu. So there are two situations. In the first situation, assume that the integrating factor mu is a function of x only. So if mu is a function of x only, if you look at here, on the left hand side, you differentiate with respect to y. However, there is a product of mu and psi x. Mu is a function of x, so product rule does not apply. You simply get mu times psi yx. In the right hand side, you find d mu dx due to the product rule times psi y plus mu times psi xy. And it is very clear that you can get differential equation for d mu dx. So you isolate d mu dx on the left hand side, d mu dx. On the right hand side, so you see that d mu dx is multiplied by psi y, so you divide everything by psi y, and then you collect other terms. What you see is psi yx minus psi xy times mu, and this relationship is easy to understand. There is a sequence. So if you look at in the left hand side, d mu dx, on the right hand side in the denominator is psi y. So here is x, here is y. The numerator, it starts with psi yx minus psi xy. So you're differentiating with respect to x, or you are assuming that mu is a function of x. So psi yx minus psi xy. If you now assume that mu is a function of y only, then similarly you can write d mu dy equals. So if you look at on the left hand side, you see the d mu dy times psi x. So you take psi x to the right hand side, you divide by psi x. Then you are going to get two terms. If you look at on the right hand side, mu is a function of y. Here it comes out of the derivative, so you have psi xy minus, from the left hand side you are getting psi yx multiplied by mu. So we have a two scenario, one for mu as a function of x and the other for mu as a function of y. And we don't need to memorize any formula. Instead, if we understand these steps, we can solve the problem. Now I'm going to show an example how to apply this technique. So we want to solve this differential equation, which is written in the form of dy dx times 2xy minus e to the minus 2y plus y equals 0. I am told that this equation is not exact, and I want to find an integrating factor, but I don't know whether the integrating factor mu is a function of x or a function of y. That has to be determined. So first thing, we write the equation in the form of psi x dx, where psi x is y plus psi y dy, where psi y is 2x minus e to the minus 2y. Just for clarity, write down here psi x dx plus psi y dy. So we know this quantity is psi x and this quantity is psi y. So since we're going to use the mixed partial derivative, so it's a good idea to calculate that here. So psi yx. So psi x is y. Psi yx means you differentiate with respect to y. So differentiate with respect to y. This is psi x, which is y. You differentiate with respect to y, you get 1. Now psi xy. So you differentiate psi y with respect to x. Psi y is this 2xy minus e to the minus 2y. So you get 2y when you differentiate with respect to x, because the second part is going to be 0. So now we are going to form d mu dx. So in the denominator we have psi y, numerator psi yx minus psi xy times mu. Substitute the value. Psi yx is 1, psi xy is minus 2y, psi y, which is 2xy e to the minus 2y. And now we see that we have found a differential equation for d mu dx, but it is not separable because this part is a function of xy, so we cannot separate it. So we are going to try the other option, d mu dy. So psi x in the denominator, psi xy minus psi yx times mu. Now substitute the values. Psi x is y, psi xy, which is 2y, minus psi yx, which is 1, times mu. what you can see here in this case, you have a separable differential equation. You can separate mu and y. So you can write d mu divided by mu equals, you divide by y, so 2 minus 1 by y dy. However, in the previous case, in this situation where d mu dx equals this quantity is not separable, 1 minus 2y divided because of the 2x term, 2xy term, so it is not separable, so we rule out this one. And what we have here is very easy to solve. You just integrate, so you get ln of mu on the right hand side 2, so its integration with respect to y is 2y minus ln of y. Now it's nice thing here, I have to find mu, but you have to be careful to look at some trick. So you have ln of mu equals 2y minus ln of y. So this is just high school algebra. You have to think of how do you solve it. So because you have seen here ln, so you want to convert 2y to ln, and you know that ln of e to the 2y is 2y. So you get ln. So once you have ln e to the 2y minus ln of y, so you can use the ln formula, which is going to be e to the 2y divided by y. Now you have both sides ln, so ln of mu is ln of e to the y by y, so you can cancel ln, so you get mu equals e to the 2y divided by y, and which is the integrating factor. Now we go back to the differential equation and we write down the differential equation and solve it. So the differential equation is y dx, you multiply by the integrating factor, which is e to the 2y divided by y, you multiply by this quantity, plus e to the 2y divided by y, which is the integrating factor, multiply the second term, so you have multiplied everything by the integrating factor right hand side also. 0 times the integrating factor is 0, so it doesn't affect, just ignore the right hand side. Now in order to solve this, you think of psi x dx. That's the trick. The exact differential, it has to be psi x dx plus psi y dy equals 0. So that's the formula for, that's the form for exact differential. So the potential is psi and we want to find psi. So now we compare what is psi x and what is psi y. So psi x is e to the 2y by y times y, the coefficient of dx, but y get cancels, which is nice. Psi x is a very simple quantity, e to the 2y, and that now you don't need to memorize a step here, is because psi x equals e to the 2y. So you think of what can be done next. So this is the derivative on the left hand side and you want to find psi. So obviously you have to look at the antiderivative of psi x, which is psi. So take the antiderivative on the right hand side, which would be half e to the 2y. On the right hand side you have to do it with respect to x, so it will be x e to the 2y. So that type of thing happens because you might be thinking that right hand side is a function of y and you integrate with respect to y. No, it's because you're looking at the derivative with respect to x on the left hand side. So once you integrate, you have a constant of integration, and obviously this is going to be a function of y because y is a variable which you are assuming this is a constant. So the next step, now we have a trick, and we have to follow that to find a. So what we can do is, because from here we know psi y, so what is psi y is given here. So then we differentiate psi to get psi y. So differentiate with respect to y, so you get 2x e to the 2y plus h prime y. Okay, so this is psi y from here, and this is psi y from there, and they must be equal. So you set them equal. When you set them equal, you multiply, so you get 2x e to the 2y minus when you multiply e to the 2y, e to the negative 2y get cancelled, so 1 over y. Okay. Now you compare both sides. You see this quantity and this quantity both are equal on the both sides, so they get cancelled. It's very easy. Y prime y, h prime y is now minus 1 over y, and you find h ln of y. Now you have everything to get the potential psi. Psi equals here. Psi equals x e to the 2y plus h. H is here. X e to the 2y plus h, but h is minus ln of y, so minus ln of y equals c, and this is the solution in the implicit form. And this one obviously we cannot find the explicit form, so we leave the solution in the implicit form. Thank you very much. Thank you for watching.